I'd like to thank everybody for coming in here today and attending our webinar presented by Canadian LiDAR, or Canadian LiDAR is putting it on for Nextcore. Just a little bit of housekeeping before we get started here today. The purpose of this webinar today is to show you a tool that can maybe help you change the way you work. So whether you can provide a new deliverable, or maybe you can do something you're doing currently, but doing it a bit faster or better. And then maybe even making better decisions because you have better data or more information. So the process of the meeting, we're going to be about an hour, I think. I don't even know if we'll be that long, depends on the questions and how deep we dive into stuff. But no surprise here, it's a webinar. And it's a relaxed atmosphere. So if you guys have any questions or anything, just put your hand up and we'll answer it at the time, because it's never easy going back to try to help answer your question. When we're on the topic, it's a little bit easier. So just the flow, we're going to go through the product, where it's from, how it's built, some specifications, a few other things, aircraft that it fits on, accuracies, and a few other things. So and at the end, hopefully the payoff and the reward is hopefully this product, answers some of the questions that, keep you guys up at night. Whether, how do I get a 4-day topo done in half a day? How do I get better deliverables to my customers? How do I use my existing fleet of aircraft to do more work? So that's kind of what we're hoping you guys get out of here at the end. And, for us, we're really happy to be bringing this product to Canada, and bringing it to the market. We had a lot of people sign up for this webinar today. I think, I had a little mess up on my time zones here. So I think that's why we're not showing quite as many, but based on what we saw, it was great. So before I turn it over, I'm going to just say who I am and who Canadian LiDAR is, and then I'll hand it over to Ashley at Nextcore. So I am Dennis Wally. I'm a married father of 4, hockey coach. I've been selling, peddling, tech supporting survey equipment in the Canadian geospatial market for about 15 years. And about a year ago, to myself and 2 former, customers, I guess, we formed a company called Canadian LiDAR Mapping. So it was sort of built or created out of, we wanted to build a mobile mapping system, which we did. If you check out canadianlidar.ca, we've got it's almost together. But anyways, we formed a company, and they own a civil engineering company. They have UAVs with LiDAR, GPR, autonomous boats. So anyways, we formed the company to build the mapper, and then we started looking at what we were doing, and we realized that there's a market for people that they want specialized tools, and I don't think they're scared. They just want somebody to support them and train them on them, and that's what we're really focused on doing. And we've had pain and cut our teeth and had failures, on some other projects leading up to before we get into business, and now we really think we can help people and bring tools like this to the market. So, but again, canadianlidar.ca, check us out, and we've got a bunch of different products: DJI, MLID, Ocean Alpha, but check it out. So anyways, sorry, I'll turn it over to Ashley and let him start his presentation.
That's great. Thanks, Dennis. So as Dennis mentioned, my name is Ashley Cox. I'm the Chief Operating Officer for Nextcore. And we've been operating this business for about 10 years now. But we started 10 years ago, we started as a drone services company. And we initially developed this system for our own survey crew. We thought it would be simple to make a UAV LiDAR system for mapping, and it wasn't, and we put a lot of time and effort into it. But what we ended up with was a product that looked fairly basic. It then turned into a 2nd generation system that you see behind me, and the 3rd generation system that we've just launched called the Lumos that I'll talk about today. I am Australian, if you couldn't get that from my accent. I'm based in a little town on the east coast of Australia called 1 Mile. And yeah, live here with my wife, my kids, and my in-laws of all things, which actually works okay. So really good to talk to you. Thank you everybody for coming today. We'll try and get through this, but as Dennis mentioned, if you've got questions along the way, just, there's a chat button there or a question and answer. We'll try and deal with those as we go through if we can, and answer any questions as you go. And there's always lots of things that we can't cover in this amount of time. So very happy to do that, or answer questions offline if that's easier as well. We've been through this, and this is an image here just of the actual Lumos product that we've just launched. And that photo was taken about 300 meters from here on the coast. So why did we build the Lumos? As I mentioned, we had a number of other generation systems. We've been selling them all over the world. And the biggest thing was that we got asked all the time is, there's a DJI M300, can you fit the system to the M300? And because of the design that we put together, the answer was no. And that was in huge demand. And then we got to a point where the M600 that we were mostly fitting our systems to was no longer in production. So we needed to move really quickly, but we wanted to create a next generation system that was going to be tick a lot of boxes. So being able to create colorized point clouds is a big request. It needed to be lighter and smaller, more accurate. And another big one that we got a lot, particularly our first international clients were in Japan, and we needed to be able to fly higher above the ground than we were currently achieving it. And most systems, to get a reliable, accurate survey, you need to fly them at about 50 meters AGL, which in steep country means you are getting very close to vegetation, power lines, things like that. And one of the things about our system that we're really proud of is that we custom built our own software. There's no third-party software in any of this. And our design is, we're not trying to solve the problem of what can you do with the LiDAR point cloud and how can you extract features and things like that. We want to get you to the point where you have a LAS file to use as quickly as possible. And so all of those things were part of the design profile that we put together. And what we came up with was the Lumos series. So there's currently 2 systems in this series, capable of accuracies between 40 and 50 millimeters. The highest spec system you can fly up to 120 meters. The other one you can still fly up to 100 meters. And it's really simple to use. The attachment here, you can have on and off in a couple of minutes using the sky mount. Now I've got the M300 here. There's other systems that we can fit to. Basically anything that can carry this payload, we can customize a design to make that work. And so, because what we're getting is a lot of demand to fit to other systems now all over the world, India, Japan, USA, Canada, there's a lot more systems on the market now that we're getting asked to fit to, and so it needed to be really compatible with all of those. One of the other interesting things is most of these systems, despite their significant expense, will only come with a 1-year warranty. And we've designed our system, we've tested it here in Australia over the last 7 years. And so robustness and the ability to continue using it. Some of our first generation units are still out in the field in very difficult, trying conditions. And we don't need to get these things back for a service or anything like that. They're self-contained. As long as they don't crash, everything's okay for them to use.
Ashley, if I just jump in for a sec.
Please.
Just on mounting on different crafts other than the M300, it's like there's no, just to bring it up, there's no integration required with the UAV or the flight software. It's basically power, mounting and power would be all that you require. So I just want to say that, because to me that's for someone who's got a big heavy lift already. Yep. Integrating can sometimes be painful, and this one will not be.
Absolutely, yeah.
Sorry.
No, thank you. That's great. So key elements are that higher altitude. That's something we really pushed on. If you do that, you reduce your scanning time, you increase your safety margin, and I'll show you in a video soon. But the post processing is very simple. Now these systems will get 2 to 3 returns depending on which system you go with. And the other thing is most systems on the market, but generally if they only have 1 antenna, you'll notice we have 2 antennas on the top of our system. If you only have 1, you need to calibrate in flight. So you need to take off, fly a figure 8, go do your mission, come back, fly another figure 8, land. And you need to do that every single time. and the time for that really adds up. And so by using a dual antenna system, we turn on, there's lights down the side, green means go, we take off, we start scanning. So that saves a lot of time and a lot of messing around. It means you don't have, missed calibrations and things like that. And we make everything here in Australia. Other than the actual laser scanner itself, everything else is sourced here in Australia, assembled here in our office in Newcastle, and so we've got a lot of control over the quality and how these things are produced. This gives you a bit of an idea. One of the really interesting things about the new sensor is that the intensity that we get from the system is a lot better. So this is our RN50 system. This was our second generation system, flying exactly the same field. So you can see that the intensity and the delineation that you can get from your data set it's a lot better. You can without colorization, you can make out a lot of features in the data just looking at a pure LAS file, which is really interesting. This is another graph that just shows you the difference between the noise. And this is fairly common with most systems that work within certain accuracies. The red dots that you see here are our old generation system, still within spec, but flying at 50 meters AGL. The blue dots are from our Lumos series flown at, I think this was at 80 meters AGL. So you get a far more precise point cloud, and you can see from that it's a vastly improved outcome, which is exactly what you're looking for in a point cloud. I'm hoping this is going to play. Yes, it is. Okay, so this is our software. This is just a video, I guess, to show how quickly you can process. But essentially, when you go and fly, this is what you'll see. You'll see your flight lines that you've done. Now, you don't normally crosshatch like this. We were doing some testing on this particular flight. You normally just fly in one unidirection, and all of the flight lines are automatically detected. And we want to remove these corners out of the turning from our flight lines. Now, our system's able to guess those. We've used the term guess flight lines, but as long as you fly a nice straight mission, then you'll be able to do that, very quickly. You'll be able to just guess them and move on to the next stage, which is uploading your RINEX data. So from your base station or from a cores network or whatever you've got access to RINEX data, it will detect that RINEX data and say, yes, that's within the scope of the mission. You process that, and then you basically just need to decide how you would like to fuse your data. What are the key elements that you would like to extract from it? How far away are the points that you would like? You can see here it's just produced a point cloud. So it's that quick to use. It basically you upload that data, you upload your RINEX, and from there it will extract and you'll be able to go to a point cloud. That's our intention, is get you to a LAS file as quickly and easily as possible. So the sort of parameters you can select are how far away are the points from the actual UAV, which points would I like to, how many points would I like to collect? So one of the things that people often look for is what's the maximum number of points per square meter that I can get. The answer to that with UAV LiDAR is you don't want that many points. If you fly slow enough, you will get more points than you ever want to use. It's about quality points. And so what we try and do is allow you to what we call decimate the data. So you actually select less points, but get the system to choose the best points out of the system. And then it's easier for you to run on your computer to be able to actually look at the data. So it's not like aerial LiDAR from a manned aircraft where you're flying very high and you're struggling to get a point density that you would like. You are getting far more points than you need, and it's about identifying what are the actual points that you want to extract from the system. I will move on if I can.
Yeah, one of the, just to chime in there, Ashley, too. Sorry, one of the best things that I can see from that processing software too is it's included with the system.
Yep.
It's included with the system, and it doesn't require a a computer, like we have a computer for photogrammetry processing we call Megatron, right? Because it squeals and heats up and does all kinds of stuff to chug through it. So this can be, correct me if I'm wrong, but this can be processed on anything with an internet connection, right? So as long as you have a hard drive big enough to upload the data, you're good. So
yeah, you don't need anything special. In fact, reviewing the data on your laptop is more hardware intensive than actually processing it. We basically do the hardcore processing for you, and that's done to make it quick. We have plenty of customers who will actually review their data in the field. So you can review the data in the field without doing the full post-processing. Make sure you got the coverage that you thought you would get. And then they'll upload their data, drive back to the office, and it's ready for them when they get back there. You know, a half-hour mission at the moment, people are processing in about 5 minutes, all of that data that they need. So super fast to be able to get to where they are. So this is to outline the 100 and the 120. Effectively, they look exactly the same, except that the actual laser scanner on the 120 is smaller and lighter. Recommended flight heights, we would normally, if you can get away with it, we would recommend you fly about 20 meters lower than these max flight heights, just to ensure that you've got what you need. But if you need to, and you're flying in super steep terrain and you want to be at 120 meters, you'll get good results. It's just that the lower that you get, the better your returns, and more chances of you getting multiple returns back from the system as well. So you've got a minimal difference in weight, 1.5 versus 1.8 kilos. And with the 100, you'll get 2 returns, and with the 120, you'll get 3 returns. So it's better, obviously better to have a lighter, more powerful system, but it's just an option for customers depending on where they'd like to go. The other features that we're working on, we're actually ahead of schedule at the moment, which is looking very promising, is that we are developing, and we'll have ready about March, is a mobile laser scanner solution. So you'll be able to mount this system, and I've got some drawings of this further along, onto your vehicle. We use mobile laser scanners for another one of our businesses. So this technology works super well as a mobile laser scanner. There's no issues there. And also being able to mount a camera on your UAV so that you can collect data for colorization as well. So you can colorize your point cloud. Ooh, seem to have gone backwards here. Just some specifications, give you an idea of the size and how the system works. Probably better to look at the actual unit. This was our first unit that we produced. This was a 3D mock-up of what we were creating, and here's the final product. And you'll notice there's lights down the side. Basically, green means go. So if you get these green lights you need, you're capturing LiDAR, GNSS, storage, you're good to go. And then the ability to attach a camera, obviously, if you're doing that. So that gives you a lot of confidence that you're collecting the data that you need, that the system's worked. If it comes back to you, all those lights are green, you've had a successful mission. It hasn't lost GPS somewhere or something's gone wrong.
I think I know, but I want to illustrate the point. But so like when you go to the field, you'd attach this to the M300, you'd press the power button, wait for all the lights to go green, and then plan your mission on your smart controller, and away you go. And if you come back for battery changes, you don't touch it, right? You just deal with the aircraft, and that's it.
Yeah, to be honest, you don't even press that button. So you put a USB stick in the side. The reason we do that is we want to collect as much data and double the collection of that data. So what happens is there's a hard drive inside. It will, as soon as you fire up the drone, it will turn on the LiDAR and it will prep you and say it's ready to start scanning. As soon as you take off, it will automatically spin up the LiDAR and start collecting data for you. So all that's automated. The only reason we have the button there is sometimes people don't have a connection between the drone and the LiDAR system, and they want to do it manually. We try and automate that because we have our own survey team, and if you have too many steps in the process, it's more steps that can go wrong. In Australia, we might send our team on a 6-hour flight and then a 6-hour drive to get to a site to conduct a survey. If they miss a flight line, out of that survey, and when they come back to the office, that's a huge problem. That blows the job out. So we've tried to automate as many problems that can and do go wrong as possible to stop that from happening. So yeah, your USB drive will be in the side. As soon as it lands, it will copy all of that data across to the USB drive. So you now got 2 copies. So good data hygiene, you've got 2 copies. You're then going to immediately copy that across to another platform, either review it on your laptop or put it onto a hard drive. And that data will stay on the Nextcore system for probably the next day or 2 of scanning until it becomes the last known one, and then it will get written over. So maintaining data, that's the only reason you're going out in the field it's the data, and we prioritize that in terms of how you collect it and then how you manage it with your workflow. So these are some of the mock-ups of the mounting attachments. As I said, we actually mount these systems to trains or very similar systems. So we're very experienced with it. You need a new antenna set to be able to mount it to a vehicle. You've got different problems going on in the vehicle as you do to a drone. But effectively, you'll be able to take the system, attach it. It'll take you about 5 minutes to move it from UAV ready to vehicle ready, and then you can mount it on your car. This is becoming increasingly important to our survey team. Often they will just collect data from a mobile laser scanner as well to add to the data that they're collecting. It's going to allow for a better spread, better returns from the ground. If you're driving through a forest, for example, you're going to get a lot more ground returns that you can add to your data set, and it just helps fill in the gaps, as well as you can cover a much bigger area. If you are restricted in how far you can fly your UAV, as most people are, then a vehicle allows you to just sit and scan all day. Brings about the question, how fast can you drive with it? Great question. It's basically, it depends how many points you want to get per square meter. That we have the same systems on trains doing 160 kilometers an hour. So, 100 miles an hour. And we collect plenty of points. It just depends what you want to do with that. The accuracy will remain the same. So if you're driving faster than that, I suspect you're not driving through Canada, but yeah.
Yeah, it's like what UAV is 10 meters a second, so that's what 40 kilometers an hour. So twice as fast. If you do 80, your points are twice as far apart. So
exactly right.
As you can see in the point clouds he showed, the data is probably a few centimeters apart. So if you're just doing civil topo for cross sections and stuff, way more data than you need for sure.
Exactly right. And then the picture that you see here on the right is that's that same field that I showed you with the intensity returns before. And this is the camera that's attached to it, collecting at exactly the same time, same heights, and it's now able to colorize your point cloud as well. So colorization is something we've been asked for a long time. The problem that we had is most of the sensors, whilst they'll claim that you can be 120 meters AGL or 100 or even 80, most of them weren't really operational above 40 or 50 meters. And so if you're trying to collect camera data at the same time, you've got a lot of photos that you need to try and stitch. It becomes very data intensive. So by achieving the flight height, it's allowed us to move into a realistic colorization scenario rather than what is really a hopeful one, where effectively you kind of need to fly 2 missions anyway, even though you've got a camera attached. So it didn't really benefit from that. So what we might do now, I've got a few videos here, Dennis. I'm going to load those up and hopefully share them, and I'll get you to talk us through them. But these are going to show the data that we've created in the system.
Yeah, and I'm just to let everybody know too, I'm going to put these, if you go to canadianlidar.ca, and we have one tab for Nextcore at the very bottom. They're not there yet, but afterwards I'm going to put the data sheets are on there, and some of the spec sheets, and then you get you'll be able to download the data. Their last files, they're not huge. That's the other thing I find about this. So when Ashley first started sending me data files, I was expecting gigabytes, and it's kind of like 80 to 90 or 90,000 megabytes, and there's tons of data there. So their software does a good job of getting rid of the stuff that you don't want. So
Exactly. Yeah.
Yep. So which one? Want to start with the Aqueduct one?
Yes, I was trying to do that, and I'm having a little bit of trouble getting it to show in the window for some reason. Share.
Yeah, while Ashley's doing that, I'll explain. He was explaining about the camera matching the LiDAR. We have that exact same problem with the system that we have on the engineering side. What's it saying there?
I'm having a bit of trouble. I can get it going, but I'm having trouble sharing it for some reason.
Yeah.
Let me try again. Can you see that now? Is that video running?
Can't see it. No.
Okay. Do you want to try running it from your end, Dennis?
Yeah. Just hold on a sec.
Yeah.
That's one thing with the time zones, trying to
yeah, so on that point, I should talk about support. So obviously, first level support is provided by Dennis. Really, the way we define that is anything that's in the manual, and so you should be able to sort yourself out with most problems. We don't get a lot of requirements for a system to be returned back to Australia. Generally, it might be a software update, it might be a calibration file update, and that, that's normally something that we can fix in our offices. So it's actually an advantage being on the other side of the world, although the timeframes don't line up for meetings like this. Often we can work on it. If you've had trouble with a data set, we can try and work on that overnight, and generally we'll aim to turn something around in 24 hours, depending on the complexity of the problem. That's working, Dennis. Thank you.
You see that? So can you hear me there?
Yep.
Okay, so this is I think it's an Aqueduct. Ashley can probably talk to it, but I just wanted to show everybody. We've just kind of got it in grayscale here, so it's interesting. You can see the flight lines. This is like a dry concrete bed down here, but it's just interesting. You can see the flight lines in it, which I thought was interesting. But yeah, so I'm still amazed at how some of this stuff, it always seems bigger than it actually is, right? So those are 5 meter contours on the colors. So what we're going to do here, we're going to do a cross section across the opening, and I'm always amazed every time I look at this data just how clear the ground comes up. Some of this is bare earth, other areas it's vegetation, and I got to think it's fairly thick vegetation because your stuff doesn't die in the wintertime like ours does. Right? So yeah, you can see there that it's pretty clean data set. And this would have been a flight, I'm assuming, right? Maybe
yeah,
two,
absolutely.
actually, or I don't know if you flew it.
Yeah, that's right. So
I think
you're right. Go for it.
Yeah, and I think it's 300 meters long. It's like a 300 meter L, so it's 300 meters one way, 300 meters the other. So nice clean data there again, right? No noise. You can see all I think the top part's concrete, the bottom part it's kind of like a riprap rock that it looks like, but yeah, it's interesting to look at it there. And then down here, it looks like they've done some blasting, so they've got a bit of they got some benches in there. Now, if you had to come at it, it looks like they came at it from the one direction. They don't have the face of the bench, but if you had to come at it from face on, you would have got them for sure. But yeah, definitely lots of detail and stuff there. But so yeah, so if that's a 40-minute flight, you're going to be 20 minutes. You're going to be 20 minutes after the flight to get to that. So
yeah. So generally, your coverage
set.
is we get asked lots of questions. How much can you cover? And it's like, well, if you want to fly fast and high, and you're not looking for a survey spec scan, you can cover 100 hectares if you want, but it's really about how fast you can fly the drone. It's all dependent on what is the problem that you're tackling. Something like this, where you've got lots of vegetation, so a power line survey, you need to get those returns from the ground. So if you've got thick vegetation, you want to slow down, throw more points at the ground, and increase your chances of hitting the ground. I think in this case, it was more about the vegetation separation for the power lines. And one of the things we've really noticed about this system is how well it gets power lines. Because of the precision of the laser scanner, you're able to delineate power lines, really, really clearly. So it's particularly well suited to that.
Yeah, this one's a good example too. I'll just point out the ground penetration and how clean the bottom of the ground, like how clean the ground appears. And we got, 17 feet. So what's that? A 50-foot tree, a 50-foot green lush tree, right? So it's that really illustrates how well the system gets through to the ground. And
yeah, we don't really have any deciduous trees in Australia, so we've got permanent state of green and growing weeds and things like that to get through. So and then places like Japan, they have super steep country, and wherever it's really steep, it's very, very thick vegetation. So getting those ground returns is absolutely vital for places like New Zealand and Japan, where you've got earthquakes and things to worry about as well.
So this would be a great data set if you're worried about like cable heights over wire or clearances over roads, stuff like that. But again, that's the top of a sign there. I missed it in the window in. I should have got it. But again, I think when I measure these bushes are 7 meters high. So it's just unreal. Like hard to get a rover in there, right? Like they're just big enough to be, I guess 20 feet, right? They're a pain in the butt, right? And that's got great data underneath of it. And then down here, there's again, the other thing I wanted to show here in this video, or if I can pause it on time, right there. So, for people on here who maybe do utilities or other things, the fact that you can actually see the word escapes me, like the line ties or the support ties, right? So you can actually see those in the data on the flyby, which is nice to see. And you can see all kinds of, support lines, other different things, right? There's the power coming into these buildings and stuff you can see there as well too, right? And then over here, I just windowed in. I just realized this in the data last night. I've had this point cloud for months, and I just realized that there's actually stockpiles in here. So, but just a good example of how you can see detail and stuff. Like, again, there was one blind spot here just because they came at it from one direction, but good detail where on photogrammetry in those areas you might not have, especially if it's shaded, right? You're not going to have necessarily good point cloud depending on what it looks like. But yeah, that's that one. So that's that. And then the next one we have here is, this is a transmission. So it's more power lines, but this one I find is interesting from the standpoint that it does do a river crossing or a brook, or I guess it's a river. It's decently big.
Just a question that came up in the chat there, Dennis, around do we have any features to get rid of false water surface scans? The answer is no to really any sort of data management or determining what's what in the point cloud. We just produce a point cloud. There's a growing number of companies that are in that space. One of the ones I've been using more recently is ScanX. It's a cloud-based one, and they're working on a ton of noise reduction features and feature extraction. I just want to see my ground returns, and you just click a button and it does it in the cloud for you. So we're very conscious of not getting into the space of really doing any feature extraction or data management. We produce that LAS file as it's collected, and then use other software, and we can make recommendations about other software to do that. Generally with water, we don't get too many because we're sort of pointed mostly straight down as we fly over the water, generally you'll just get 0 returns. That's quite common. But yes, you can get some surface returns if the water's rough and you've got lots of reflections back that way.
Yeah, another one. So ScanX is a good one. Another one that that we're affiliated with too is Global Mapper.
Yeah.
It's not cloud-based, but the nice thing is about that is, you know, let's say you had provincial LiDAR, right, and you want to ground truth your LiDAR, you can bring both. If you had an offset, you can match them. So there's a bunch of different stuff in there. So Global Mapper's got a good set of tools, and it's not cloud-based, but it is subscription-based. So, but good tool for that. And then I've got one last one here I'll show you guys. And this is sort of the data set that Ashley was showing before. So the baseball park or baseball field, and then the intersection.
This is the most scanned section of the planet. I think we do all of our tests.
And I like this system too, because your lines show up, which is nice too. So if you're going in to start to do some drafting in 2D, you've got some lines to work with, you've got some curve to work with. So so this is the turning circle in 3D. You know, you can see some the car, those weird blue things are the blue car is moving, but yeah, you can make out some decent detail here on the curves and stuff, right?
Yeah, absolutely.
So,
the
again,
reflectivity
probably
of
not
is really on display with this sort of data set, particularly roads. You know, the difference between white and black lines really shows you how much, you know, comes out from it.
Yeah, and like the only reason I showed that is because it's very good from the air. I can only imagine how good though detailed those curves and stuff will be when it's on the back of a vehicle and it's 5 meters away. So, but yeah, here's, you know, just another section here with the pool and stuff. So we just thought I'd show everybody. So again, nice. You kind of get everything that's on the lot, right? Yep. Building corners, the utility locations, the tie-ins, that kind of thing. So you get a fair bit of detail just from a kind of a single pass across it. And you can see the road noise is pretty clean there. So it gives you a pretty good understanding of what's going on there. And then lastly, we're going to look at, so these trees, I didn't measure them in the video, but I think they're like that 20, 15 to 20 type height, right? And they're full. And then I'll just show the data that's underneath of them. And I like color by elevation. I'm not sure why, but I do. But it just seems to show up a bit better. So these are the higher the trees in there too. So I just wanted people to see kind of when you come underneath one of these trees, what it looks like. So more than enough information for, if you're doing surveys for a developer, right, who wants to just figure out if he wants to buy a piece of land or something like that. It's like you can go in and do original ground topo very easily in big, tall trees and not think twice about it, right?
Yep, exactly.
And this is another one here. This video is a little, feels long when I'm talking, but there's another big section of trees here with some buildings and stuff in here. So it's interesting. You can see under all those trees, you're still able to get, the original ground that's in there. They've got, it looks like, I'm guessing it gets hot in Australia or super hot because it's like all your benches are under trees and stuff, which is a good idea. So, but yep. There's not great detail on the benches, but if it was ground, you could tell that it's what it is. So here's the diamond. But I just wanted to show, how you can kind of see, like the pitcher's mound is elevated there. So if you go to color by elevation, nope, wrong one. Should edit that out. So you can see, in that data, so pitcher's mound is, 18 inches, 12 inches. So you can see a nice uniform shape that you get on it based on that. So, but the data is nice and clean, but you can still see the mound in the data. So I just thought that was interesting to show that how clean the data is. So
Yeah. We've just got a really good question there, Dennis, regarding security for the cloud-based processing. It's a good question because it's one that we do get asked because your clients do have a growing concern around where their data is going and where is it. All of our servers at the moment are based here in Australia, although we're building some servers up in the US as well. We are ISO 27001 certified. I've got that right, yes, which is your information security certification. So we've got all the processes and protocols in place to keep data safe. The other thing is that you can assure your clients is we're not actually taking your LiDAR data. That's not going into the cloud at all. The only thing that's going into the cloud is the flight trajectory of the drone and the Rhinex. And all we're doing is sending back to you a post-processed flight trajectory, which is smoother. So because if we can't give that to the actual point cloud, then that's where you get variations in your point cloud. So that's all we're doing in that cloud-based process. The rest is all happening on your laptop. And basically it's saying, here's a new flight line that's been smoothed out with GPS and Rhinex. And now you've got a nice smooth trajectory that you can fuse your point cloud over the top. So your clients can be assured that there's actually nothing really of value for someone if they were to get that data. All they would know is where your drone was flying and when. So it's a fairly secure and not really a high risk sort of thing that's being managed there.
Maybe similar to using VRS corrections coming out of the US, or base stations on buildings in Canada but being processed somewhere else. But actually that reminded me of something. Maybe you didn't mention the processing, why it's not why it's free, but why it's included and how that's part of your guys' other business. Might be worth mentioning.
Yeah, great question. So we, as I mentioned before, we make systems that fit on the front of trains. We have permanently installed systems in the US, the UK, Australia. Australia alone, we probably do about 80 to 100,000 kilometers of scanning every year on one vehicle. So we're constantly doing that post-processing for those systems. So our customers using this data for post-processing for the flight trajectory and uploading that into our cloud is a very, very small proportion of the processing that we do. And so we don't need to charge for it. It's not a huge cost for us to do that. And, subscription models are great for companies to go, oh, look at all this recurring revenue that we've got. But we just found it was a complication in the sales process. It's like, here's a system, you get the processing included, whether you use it for MLS or whatever, and there you go. So we provided that software. We've had customers using our software now for 5-6 years. There's no additional fees for that, and we upgrade it over time. So we're constantly working on improving the software and listening to customers about what they want in the software, so that they can continue to use it. So the other thing that I just wanted to cover off on is around the actual manufacturing of the products. Like everyone, we are victims of the chip shortage at the moment, and we're having to plan well in advance to try and determine how many units to build, what our customers are going to want, whether it's an XM or an XT, make sure that all the components are in place. And we're ordering in like lots of 50 at the moment for a lot of those small components to make sure that we can get things built on time. So worst case scenario for us is if we have an order, it could take us 3 months to build one, as in we don't have the enough of the key components that we need to make it happen. We're endeavoring to build enough to keep them on the shelves so that they can ship same day, and we used to do that with the RN series that we used to produce. However, that's with the demand and the chip shortages that we're having, we as much notice as we can get as possible that you're even looking to buy one will allow us to better estimate how many units we need to build. And then we're just taking a small deposit from customers if they would like one built. And from that, we'll come back to you with a expected delivery date based on what components we've got in-house. So it could be a week's turnaround if we've got all the components in-house. If not, we could be looking at a month or 2 months. But generally at the moment, it's probably about 6 weeks from initial order to shipping, and hopefully that will get better and not worse. But that's where we're up to at the moment, which is very frustrating, but is what it is. Oh, Dennis, you're on mute. We can't hear you there.
Sorry about that. I had kids leaving for work, so they were screaming at each other where their clothes were. But no, I was just going to say it's a weird problem to have. So, and we talked about this with a couple of the other customers that we've been quoting, and it's like, yeah, it's like the deposit, it holds your spot, and if the world changes in 3 months when it's ready, then it's not the end of the world. But we need to, if you need something for when the snow melts, we need to start planning now and stuff like that. So
yep.
The other thing on top of that too, the nice thing, if you're an existing UAV user and you've tried to lease stuff, because the insurance can be kind of tough with UAVs and stuff in Canada for leasing. So the nice thing about this system, it goes on a vehicle, so we can call it a mobile mapper and not a UAV. So we think we successfully navigated that a little bit. So for people who are looking to finance and stuff like that, we can definitely help you out with that. So yes.
Excellent. That's a good trick. I might see where else I can apply that.
Yeah, the insurance is almost ends up being as much as your payment, right? Unfortunately, for the UAVs. So.
Yeah, there's plenty of examples of countries that have a very similar problem, and it's getting worse, not better. So thank you everyone for tuning in. If you have any more questions, please feel free to ask them or to hit Dennis up. And if he can't answer them, I will. And if I can't, I'll find one of my boffins at work who can get an answer for you.
Yeah, and if everybody before they leave, if they could just drop their emails in the chat window or the question window, that way I'll have it and I can fire off some more information. We can send you the recording if you guys, a couple people I saw come in late, so if you missed it, I can make sure you guys get that. As well as we can communicate if you guys want me to send you those videos directly so you can share them in the office or the data sheets and stuff. But I'm hoping to have that up on the website tomorrow, if not by Monday. So CanadianLiDAR.ca. So, all right, everybody, thank you for attending, and hopefully maybe we'll do one of these again, maybe in another month as well. But this time I will not mess up the time zone. So I apologize if somebody had to rearrange their day or had to miss it. If you're watching the recording and you had to miss it, I apologize. So appreciate everybody attending.
Thanks, Dennis. Thanks, everyone.
All right. See you guys. Bye now.
Yeah.